Hi, my name is Talia, and I'm an incoming high school senior who's super passionate about math and chemistry and teaching others and helping them learn both math and chemistry. I want to go into a career in education, and I started this YouTube channel as kind of a supplemental resource to anyone who may be having difficulty learning certain chemistry topics in their classes. I've been going in order of the topics I learned in honors chemistry and kind of just reteaching them to you guys. So in our previous video, we learned about density. In this video, we are going to dive into a whole new unit, starting with talking about atomic history, atomic mass, and isotopes. So if you need help with those concepts, you are welcome to continue watching. And without further ado, let's get started. So we are going to start today's video by talking about atomic history and basically some scientists that made very groundbreaking discoveries in the world of chemistry. So we are going to start with John Dalton, who discovered atomic theory. And atomic theory basically states that all matter is made of atoms, and each element, which you can see on the periodic table, has its own kind of atom. Atoms cannot be created or destroyed, and molecules are formed when atoms are combined. Next, we have Joseph John Johnson. So Joseph John Johnson basically discovered the electron because he discovered that there were particles around a positive mass in the center of an atom that were negatively charged. Next, we have Ernest Rutherford, and he discovered the nucleus by creating a nuclear model, which basically explained that an atom has a positively charged nucleus in the center that has protons, and protons make up most of the mass, and then it is surrounded by negatively charged electrons around it. He also used the gold foil experiment, which I've included a picture of up here, which basically there was a layer of gold and it was hit with fast moving positively charged alpha particles, which you will learn about in nuclear chemistry. And the particles that were sent backwards from the gold foil were said to have hit a nucleus because you know that positive and positive, they repel each other. So when a positive particle is shot at a positive nucleus, it is going to repel. And that is one of the ways he discovered the nucleus. Next, we have James Chadwick, who discovered the neutron. And we will learn that a neutron is a neutral particle that contributes to the mass of an atom, but not the charge. So if you look at this table down here, you have all these subatomic particles: proton, electron, and neutron. Proton has a positive charge, electron has a -1 charge, and a neutron has a neutral charge. The proton and the neutron are inside the nucleus, and they contribute to the mass of the nucleus, obviously because they're inside. The electron's mass is relatively zero, and it orbits around the nucleus. So our next concept is atomic configuration. In your chemistry classes, you've probably been given a periodic table, and if you look on the periodic table, you will notice that each element has some distinct features in its little box, and we are going to talk about those distinct features. Also, you're going to want to have your periodic table for this whole video and this whole unit and the rest of chemistry in general. So in the little box on the periodic table, each element has an atomic number, a symbol, a name, an atomic mass, and a charge for the ion. So we are going to go through all of those except for the charge for the ion, which we'll talk about later. So the name is just what the element is called, and that name is approved by IUPAC, which is an institution of chemistry. Then we have the symbol, which can be a mixture of an uppercase letter or an uppercase and a lowercase letter. There are never two uppercase letters, but for instance, like barium is BA. So you can look on your periodic table if you need help with the symbols, whether you take honors chem or AP chem, you will have the symbols on your periodic table. I also have made a periodic table on my wall. Here's a picture of it. I'm very proud of it. Then we have the atomic number, which is the amount of protons in the atom. And in a neutral atom, it is also equal to the number of electrons. So remember, protons are a positive charge, electrons are a negative charge. If the number of protons is equal to the number of electrons, the atom will be neutral. And the atomic number is found above the symbol normally. Then we have the atomic mass, which is written underneath the name, and that is just the amount of protons and neutrons. The protons and neutrons are the only subatomic particles that contribute to the mass of the atom. And so you can find atomic mass by just doing number of protons plus number of neutrons, or to find the neutrons, just subtract the number of protons from the atomic mass. And the number of protons and neutrons will always be rounded to the nearest whole number. So let's say you have an atomic mass of 75.23 and you have 40 protons. You will not have 35.23 neutrons, you will have 35. That was just a random example. Okay, so we are going to practice with atomic configuration and just work on naming the symbols. So we are going to start with the first row. We have aluminum. You can pause and do this on your own, or you can go with me. So let's start with the first row, the symbol for aluminum. If you look on your table, it is in the third row in the third column. It is Al. For potassium, it is in the fourth row in the first column. It is K. Calcium is in the fourth row in the second column, Ca. Now let's give the name of the element that matches the symbol. For Mg, if you look for the symbol, it's in the third row, second column, and that is magnesium. CO, this one is going to be more towards the middle, which is a little harder to find. But if you look, it is in the fourth row in the center, number 27, cobalt. And then we have Br, which is bromine. And now let's write how many protons each element has. So let's look for the symbol Rb. Remember, protons is equal to the atomic number. Rb, or rubidium, is number 37. So there are 37 protons. Helium has an atomic number of 2, which means there are 2 protons. And Kr, or krypton, is in the fourth row, 8th column, with 36 protons, because that is the atomic number. I'll write that down here. How many electrons does a neutral atom of the following elements have? So Ti, titanium, fourth row, fourth column, has 22 electrons, because remember, in a neutral atom, protons equal electrons. They're the same number of both. Sr, or strontium, there are 38 protons, which means a neutral atom will have 38 electrons. Xenon, and it has 54 protons and 54 electrons. Remember, I'm getting these numbers of electrons from the atomic number, which is equal to the protons and the electrons in a neutral atom. Finally, let's do how many neutrons does each element have. So if you need help, you might want to get your calculator for this. Let's first go to zirconium, which is Zr if you look for the symbol, and that is number 40. So we have 91.22 is the atomic mass, and the atomic number is 40. So we are going to subtract 40. And then remember, we're rounding to the nearest whole number. So that will get 51 neutrons. Our next example, we have chlorine. Its atomic number is 17, and the atomic mass is 35.45 AMU. And then I'm going to subtract 17 protons, and I get 18.45, but rounded to the nearest whole number, that is 18 neutrons. Next, we have neon, which is atomic number 10, and its atomic mass is 20.18 minus 10 protons. Because of the atomic number, it will give us 10 neutrons. So we are going to do this table. If you would like, you can pause and try it on your own. Highly recommend. So for the first one, we have element number 18. That element is argon with the symbol of Ar. The atomic mass is 39.95. Because the atomic number is 18, there will be 18 protons and there will be 18 electrons. And then for the neutrons, we can do 39.95 minus 18 protons, and we get 22 neutrons. Something about atomic mass, your periodic table might have 39.9 or 40 or something like that. It just depends on how far your table is rounding, but at the end of the day, you'll get the same amount of neutrons because you're rounding to the nearest whole number. Next, we have sodium. And if we look for the name sodium, the atomic number is 11. The symbol is Na. The atomic mass is 22.99. There are 11 protons because of the number, which means there are also 11 electrons. And for the neutrons, we can do 22.99 minus 11 protons equals 12 neutrons. Remember, I'm rounding neutrons to the nearest whole number. Okay, finally, we have 56 protons, which means the atomic number will be 56. And if we look, that is barium. So the atomic number 56 with the name of barium. The symbol is Ba. The atomic mass is 137.3. There are 56 electrons because it's a neutral atom. And for neutrons, we have 137.3 AMU minus 56 protons equals 81 neutrons. Okay, so we have talked about all the basic parts of an atom. Protons and neutrons contribute to the mass. Electrons orbit around the nucleus. And now we are going to move on to talking about isotopes and how to find average atomic mass. So isotopes are basically versions of an atom with the same number of protons, because that is the determining factor in what atom it is or what element it is. But there are a different number of neutrons, and that means that different isotopes have different masses. So if you look, for instance, on your periodic table, you'll notice that sulfur has a mass of about 32.06 atomic mass units. So there are different isotopes of sulfur, which means that there are different versions of the sulfur atom that have different numbers of neutrons and different atomic masses. There might be, in one sample, 70 sulfur 32s, 10 sulfur 31s, and 15 sulfur 33s. Each of those isotopes is multiplied by their abundance and added together in order to get the average atomic mass. That's how average atomic mass is found. And that is what we are going to do in some of our practice problems. So as I said here, the periodic table reflects the average atomic mass of all the samples of an element. And to calculate the atomic mass, we just multiply the atomic mass of one isotope times its abundance and just keep doing that over and over for all the isotopes and their abundances. And that'll make more sense once we practice more examples. That is just the premise of what we're doing. Now, like I said earlier, this is a representative sample, which means that a scientist did not collect all of the sulfur in the whole wide world in order to determine the average atomic mass of sulfur, but by including the abundances and making the abundance of each sulfur isotope in the sample relative to the abundance of the different sulfur isotopes in the world, the average atomic mass can carry over, and it can be said that whatever atomic mass is found in that sample is the same as the average atomic mass of sulfur. As I wrote here, we write abundance in decimal form. So there are 3 isotopes of neon: neon 20, neon 21, and neon 22. How many neutrons does each isotope have? And calculate the average atomic mass, rounding your answer to 1 decimal place. The information that you're given when finding average atomic mass can vary, but with chemistry, it's just important that you know the basic way to solve the problems, and then you're usually able to apply it to different kinds of problems. Okay, so how many neutrons does each isotope have? Let's start with neon 20. So every neon has 10 protons. So if we subtract the atomic mass minus the protons, 20 atomic mass units minus 10 protons equals 10 neutrons. For neon 21, it would be good to write the isotopes down so that you can be organized with your writing. We have 11 neutrons. And remember, isotopes have different levels of neutrons, and this makes sense because our different isotopes of neon have different numbers of neutrons. Now we have neon 22. So 22 atomic mass units minus 10 protons is 12 neutrons. Now we have the neutrons. So we have solved the first part of this problem. Next, we are going to calculate the average atomic mass of neon, rounding our answer to one decimal place. So we are just going to fill in the same equation with mass. I'll start with neon 20, and its abundance is 90.48. So I'm going to rewrite that as a decimal. So 0.9048 plus 21 times 0.0027, and then 22 plus 0.0925. Beautiful. Now we are going to plug that into your calculator, and you should get 20.1877, but we are told to round to one decimal place, so we are going to round to 20.2 atomic mass units, which works perfectly because that is where the atomic mass of neon is about. So that is how you calculate average atomic mass. So that was this week's video. I hope you enjoyed, and I hope you were able to learn a little bit more about what you're learning in your chemistry class. Next week, we will be learning about Bohr diagrams and ions. So if you need clarification on that, or you would like to learn more, you are more than welcome to click on my next video and continue along your chemistry journey with me. I also do chemistry tutoring. I will have a link to my website in the description box where you can register for a session if you would like. They are one-on-one sessions, so if you need any extra help and you would like some more private attention, you are more than welcome to do that. If you have any questions about what was covered today or anything in general, feel free to leave it in the comments and I will do my best to answer them. I hope you enjoyed this video and good luck with learning your chemistry.